In this video, we're going to go through the pre-lab for the percent yield lab. All right, so we've got this equation up at the top. So NaHCO3, which is baking soda, decomposes into NaOH, sodium hydroxide, and CO2, carbon dioxide. All right, so it says in the reaction, solid sodium hydroxide and gaseous carbon dioxide are produced. Identify which product would be easier to measure using an electronic balance, and then explain your choice. So you have a solid and a gas. Which one would be easier to measure using a balance? Again, a solid and a gas. Which one would be easier to measure? And then make sure you explain your choice. Okay, number 2 says, determine the theoretical yield of sodium hydroxide if 2.5 grams of sodium bicarbonate are used. So this is a 3-step grams to grams problem. My recommendation is to work it out on paper because your answer needs to be typed here. You're going to be typing all of your work into your lab report, so this is good practice. So I'm going to go ahead and delete this where it says type your calculations here, and I'm going to remove the highlighting. Okay, to get into the equation editor, I'm going to go up to the insert menu up at the top, and I'm going to drop down to equation. Okay, now notice there's a blue box. That's the equation editor. If I accidentally click outside of the blue box, notice it goes away. Okay. Also, when you're inside the equation editor, you'll notice this little bar right here where it says we've got some of these mathematical functions are black. If I click outside of the box, they're grayed out. Okay, so we always want to make sure that we're inside of the blue box because that is the equation editor. Okay, so I've already done the work on paper, so I'm going to go ahead and start typing it out. So 2.5 grams of NaHCO. To get a subscript, I can press Shift underscore. The underscore key is the button to the right of the 0 button on your keyboard. So it's kind of just to the right of that over by the backspace. Okay, and then I will type in 3. Now to get out of the underscore, I'm going to press the right arrow on my keyboard. Okay, now I can keep going. So that's my first part, and I know that I need to, let's see, multiply, and now I need a fraction. So if I go up to the top, it's the 4th option here, you'll see A over B. That is a fraction. So it puts me in the numerator. So I know that in my numerator, I'm going to need 1 mole NaHCO3. And, oops, see, I accidentally clicked out, so I want to make sure I click back in, and that blue box appears again. Whatever the molar mass is, I'm just going to type in a fake number. I would not put in my number, okay? So I'm going to put in, let's see, 100 grams NaHCO3. So I know that when I see 100 grams on the lab reports, someone just copied my video. Okay, so I'll keep going. So I'll do times. Here's the next fraction. So this would be what, my mole ratio. So I'd go back up here. Oh, it's 1 to 1. Look at that. 1 mole NaHCO3. And what am I going to? I'm going to NaOH. So make sure you're in the top of that fraction. 1 mole NaOH. Okay, and then make sure you're in the blue box. So clicking over here too far gets me outside. I want to make sure I'm in that blue box. And you can use the arrow keys on your keyboard too to go between the blue box and not. Okay, so times fraction. Okay, let's see, this needs to be 1 mole NaOH, and then whatever the top is here. I don't know what the molar mass is. I'm just gonna, let's make this one 300 grams of NaOH. So again, if I see those numbers pop up on your lab report, I'll know you just copied my answers. Okay. And then, of course, I would want to work this out on the calculator, and I'm going to just put in a number here. So let's say it is 521 grams NaOH. Okay, so this needs to be typed. Okay, this is not correct. I don't want to see this. Okay, you need to use the equation editor. This is not appropriate. So some people will get lazy and try to type it out like this. I don't want to see that. Okay, it needs to be done with the equation editor. Notice the difference. This is a lot cleaner and easier to understand. This looks like gobbledygook, and there aren't any units on there. Okay, it needs to be typed using the equation editor. In your lab report, you will be using the equation editor to type all of your equations, so get used to doing it here. Okay, use the data table below to calculate the actual yield of the solid product. Okay, so you've got the empty crucible, you've got the crucible with your reactant, and then you have the crucible with the solid product. So you're going to have to go back and look at your notes, and what do I need to subtract here? Since we're doing math, let's make sure that we're using the equation editor. Okay, so let's subtract the second and the third number. So 92.62 grams minus 27.96 grams, and let's say that equals 34 grams. Okay, whatever it is. But make sure you're using the equation editor and making it look nice and pretty. All right, number 4 says, using the actual yield, number 3, so here's our actual yield, 34, and the theoretical yield from number 2, so I got 521 grams, calculate the percent yield. And I just want to remind you again, I'm just making up numbers. Do not use my numbers because they will be incorrect. Okay, so let's type in some values here. So actual yield over theoretical yield, we're going to need a fraction. So if I go up to the top and I go to A over B, let's put our actual yield. So our actual yield was 34 grams and our theoretical yield was 521 grams. And let's multiply that by 100. So what do we get here? I'm not even going to do the math. I'm just going to make up another number. Let's say it is 84%. So there's my answer. All right. Number 5 says, based on the percent yield from number 4, so 84%, explain whether or not the given reaction can be ruled out as the correct reaction for the decomposition of sodium bicarbonate. Okay, so we talked about interpreting the percent yield in class. So remember, if you have so ideally we want 100%, okay, that would represent a good reaction. So if I got a really low number, that wouldn't be good. Likewise, if I got a number greater than 100%, that should also mean something. So 100 is kind of the number that we're looking for. So you need to tell me whether or not this percent yield would tell us if that reaction is correct. So in the lab, you're going to get 4 possible reactions for the decomposition of sodium bicarbonate. One of them should be close to 100% yield because it's the correct reaction. The other 3 reactions are not correct, and your percent yield should be way off from 100%. This is a pretty simple reaction. The results are usually pretty good. So whatever reaction is closest to 100% should be the correct reaction. Anything that is off with a really low or something that is over than 100%, you can rule out as incorrect. Okay? So remember, all of your equations need to be typed on the pre-lab. Make sure you are explaining your responses. Good luck.